All right. Okay, Ceph on Windows. Why porting Ceph on Windows? So Ceph is the most popular distributed open source storage solutions out there. So this is without discussion, right? And at the same time, Windows Server has a relatively large market share, especially in the enterprise. So you cannot enter a large company these days, but not even a medium-sized one, without finding a mixture, of course, of a lot of Windows servers and Linux servers and so on. So having something that will bridge the gap between them when it comes to storage, it's quite ideal in this context. Of course, this is not something that is the first time that it comes up. Actually, companies tend to use a lot the so-called CephFS cache gateway for that, but there have been always a lot of complaints related to performance and scalability for that. Okay, so that's something that we've been hearing and discussing since a long time, and finally, recently, I mean, approximately 1 year ago, we started actually doing all this work. How did it happen? It happened thanks especially to SUSE, so big kudos to SUSE for that, especially Lars and Mike for helping a lot in this effort. Working with SUSE was absolutely phenomenal for us. And we managed, thanks to this partnership, to release, to bring to the community, let's say, this particular effort for the porting. So what were the architectural goals we were looking at? To begin with, we wanted to have a user experience on Windows which was as close as possible as the Linux one. What does that mean? It means that we want to have people which have a Linux experience with Ceph to be able to just log in a Windows server and find themselves at home as much as possible without having to go completely to a new learning curve. At the same time, we wanted to make sure that also the Windows side of the equation would be well integrated, meaning that if somebody is a sysadmin or a DevOps, let's say, on the Windows side, could easily start working on the using Ceph by finally natively integrated and not just like something that doesn't feel at home at all. Okay, so those were some of our goals in terms of user experience. In terms of performance, we want definitely to outperform the iSCSI gateway, otherwise it didn't make necessarily too much sense, and get as close as possible to the Linux native performance. I will add some more info on that soon. Secure, I mean, anything which is cloud related, of course, has to take into consideration security. And in terms of platform support, we wanted to have Windows Server 2016 and 19 as default, and of course it will support also the upcoming 2022 version. It works also Windows 10 for development purposes, and of course it could theoretically work on also on previous versions, but it's not something that we plan necessarily to support at the moment. Non-goal, porting OSD directly to Windows. So right now, the way it works is that the Windows Server nodes will connect to external OSD nodes to access the storage itself. This is a very common question, especially when people ask it with how it compares, let's say, to native distributed storage options. Okay. A quick look about the architecture. So here we have the Windows side on the right. We have a separate user space and kernel space part. The user space, we have a process called Wimbidi, which contains the self-hardware, specifically Wimbidi, and also an additional component which is called the Wimbidi, how we call it, which has a DLL in user space and connects to a fast channel, as called device I/O control channel, to the Wimbidi kernel module that we developed specifically for this project. And from there, we have access to the map disk. On the other side, of course, it will connect outside of the Windows node itself to SD in order, and similarly also for CephFS to access the data itself. So talking specifically about user space, we have Wimbidi, Liberados, and all the relevant CLI components which have been ported. And by the way, all this effort, thanks a lot to the community for this, has been merged into Pacific. And we are still actively, of course, working on potential bugs that might find out, potential regressions as we move forward with the development. RBD mappings are managed by a process called RBD Wimbidi, which is very similar in scope and experience to the RBD NBD on Linux. Actually, that's where the experience, let's say, inspiration for that came from. We have three typical commands that we use: RBD, Wimbidi map, unmap, and list, specifically to RBD volumes, okay, images. Mappings are managed afterwards by a Windows service, meaning that if you reboot the host, you will find, of course, your mappings in the same identical place. From a user perspective and from a operating system perspective, the RBD images will just look like regular Windows disks, like you will expect via iSCSI or anything similar. RBD and many CLI tools themselves, of course, work exactly like on Linux. What we don't have, for example, there are a bunch of Python-specific scripts that, although they can work with some very minimal changes on Windows itself, on Windows you don't automatically associate the Python script, let's say, with an executable, so they need to be wrapped, which is something that was out of scope of what we needed. So you cannot just run Ceph and have a bunch of commands. While everything which is executable will just work out of the box. Okay, Wimbidi, that was the hardest part of the work that we did. So big kudos also to the team for that. It's a Windows kernel driver. It's a called Virtual Store Port Mini Port type of driver, which in short, without getting too much into details, is what allows basically to create storage which is backed, in this case, by a networked storage origin, and show up as disks within the operating systems. It implements the MBD protocol, so that's where we started from, with two communication options. The first one is via TCP/IP, which is compatible with any Linux MBD server. Actually, when we designed this and we worked on that, we wanted it to work like in order to be able to work, let's say, with any NDB server itself, so not only Ceph. And actually, it still allows us to do that. But performance was really not where we wanted it to be. So what we did is that we developed a separate user space kernel communication channel, which proved to be significantly faster, and allows us, of course, to reach the performance goals that we wanted. It's licensed, it's open source, of course, like everything else that we did here. LGPL 2.1 to be also consistent, let's say, with the majority of the Ceph ecosystem. And it currently resides at the GitHub repository that you can see on the link below. Now let's get a bit on how the configuration works. On Linux you will find everything in a default location, which will be etc Ceph, while on Windows the equivalent of etc will be program data. So, for example, if you have your operating system and everything in C, that would be C : /program data, and then Ceph. So very similar. Very consistent, let's say, in how it works on Linux. So the typical workflow, considering in getting ceph.conf and keyring files over from a Linux node, install Windows, the Windows binaries, and just starting everything. So very simple. Beside RBD, the second goal that we had was to get also CephFS ported. The difficulty here was due to the fact that Windows lacks natively Fuse or similar user space file system driver options. There are a bunch of them in the community, and after we looked around at the various options, we decided to go with Dokeni, which is a very stable one, works extremely well, and we are very happy with it. So that's a prereq that needs to be installed in the moment we choose CephFS on Windows. Beside that, of course, we implemented all the integrations with Dokeni, and it works like you would expect on Linux. You just start, for example, the mapping by just running ceph-docken.x-lx, and at that point, it will show up on Windows as the X volume, okay, with X mapping. Since we're talking about Windows, which until very, very recently didn't have a native package manager, we implemented also an MSI installer, which is also open source, which allows us to have seamless integrations in the Windows ecosystem. It can be fully automated, so if you want to deploy it as part, for example, of an Ansible playbook or whatever else, it just works out of the box. It's open source, as I mentioned before, and there are also continuous builds available at the link that you see below, meaning that whenever something merges in Ceph or any of the dependent components that we looked at before, like Wimbidi and so on, there is an automatic build job that will just build a new version of the installer, so you're always up to date to the latest version that we have today, which is based on Pacific at the moment. Okay, talking about Windows, it's also very important to mention virtualization. Hyper-V and Ceph were something we were really looking at integrating properly. It's worth mentioning here, I honestly forgot to add a bullet point here, that we also added OpenStack support. So if you have OpenStack with Hyper-V, now you can also have Ceph with Cinder and just make it work seamlessly on Windows as it would on Linux. Hyper-V can access now the RBD images in the form of disk, of course, and you can also, that means that you can also boot directly a VM from an RBD image. You can see there are a bunch of PowerShell commands that you can use just to create a VM, add a hard disk drive that comes from there, and start a VM. I will actually do a demo right now for that. Let's talk quickly about performance. So we had a very significant improvements over the iSCSI gateway, and in our test, we managed to outperform also the Linux native RBD scenario. Please note that that was not originally what we wanted, and is not a matter of contest. I mean, we don't want to say, hey, we are faster than Linux or whatever else. Okay, so that was really never the goal. The reason why it happened is that since we don't use the TCP/IP overhead on top of the let's say user space to kernel communication part, we have a faster communication channel, which also means that we have a improved I/O worker threads allocation. That's why this happened. And again, we try to be as objective as possible. We published a blog post with the performance results, and of course, all the methodology is in the open there. And if somebody else wants to do additional tests, we are more than happy to validate it and so on. We are obviously extremely happy about how things went. Okay. Demo time. I'm going really fast because, of course, cramming together both the demo and the slides here, it's not necessarily too easy in the short amount of time that we have. So let's start directly. So here I have a Windows machine. I already downloaded the Ceph installer, as you can see from the curl command on top. I'm quickly installing it. Here you can see what I can choose to install. I could theoretically just install the CLI components or also the Windows Ceph driver, which is what most probably we want to do. So this is relatively fast. And it's finished. Now, it will set the binaries directly in the path for you, but this way I don't have to, let's say, start a new session. Let me also get a separate console where I can SSH my Linux machine. So this is an OpenSUSE machine where we have all the Ceph cluster. Now, what else? Okay, so first let me create a Windows volume. As you can see right now, I have only one image which is called Hyper-V1 that I will use in a bit. Here I should have it as well, yes. So I can run the same command from here and I see the same identical details. This is Windows and this is Linux. All the data, all the configuration files are already in place. I already put them there so that we don't have to spend time, let's say, doing that. Okay, next thing, I'm going to create an image. It's there. And all I have to do at this point is to just map it on the Windows side. Back. And if I run this command here, I will see that we have the mapping in place. So next thing, I can just so that there will be a new disk. As you can see, Windows already recognized that there is a new disk that showed up. I can initialize it, create a volume. It's going to be called E. And this is our mapping. So if I go here on my server, I will find already my disk mapped here. So, and this comes straight out of OSD, okay? Next, quick look at the CephFS stuff. Opa. As you can see, we don't have anything created over there, so no volumes. Creating a volume. Created. There we go. And then let's switch on the Windows side and, well, actually first, let's mount it locally. So on the, now I mounted it on the Windows side, oh, sorry, on the Linux side, and that should be on MNT CephFS Demo 1. And I am just writing very quickly a file into it. So if I look there, I will find a single file which is called hello from Linux, and it contains a very simple string, like typical hello world type of things. Now let's switch to the Windows side of things. And with this command, I am actually doing the mapping on the Windows side. Back to the. Here it is. As you can see, I can see the file, I can open it, and here's my content. So I can do an equally cheesy message on the other side. And if I go back on my Linux side, I can see that the first demo, I have two files, and this is my Windows one. You can see hello. There we go. Okay, so I think I can quickly run also the Hyper-V demo. So I can terminate this mapping since I don't need it. The Windows, so specifically there is already an RBD image called Hyper-V1, which I created with this qemo command, which I don't want to run again. But just to show you, I basically converted an OpenSUSE QCOW2 directly into the RBD image, which I call Hyper-V1, which I'm not running just because it takes a few 2-3 minutes, and we don't want to spend those 2-3 minutes just waiting for that. Okay, so it's already there. So what I will do here is to just map it. I will just look it up here. So here it is. I want to put it offline. As you can see, it's already partitioned because it contains already the operating system and everything. I will start a PowerShell shell. And since it's an OpenSUSE, I will just copy it. Creating an empty VM. Add the disk and pass through. And then we can start the VM. There we go. And I can see that the VM is here. If I connect to it, I see that it's booting up. So, and again, the storage for this particular VMs comes straight out of Ceph. So there is no local storage associated with this particular virtual machine. Okay, that ends our demo. Let me go back to our slide deck. And we have Mike, do we have a minute or two for questions?
Yeah, so we got a few questions here. Can you clarify the Ceph CLI Python comment?
Yeah, sure. Let me go here. Opa. Okay, so this is all the binaries that we have at the moment installed. Okay, as you can see, there are executable and a bunch of libraries we depend on, and so on. As you can see, we didn't copy over as part of the installer any specific Python scripts that are often used, let's say, in the management of Ceph clusters. The reason is simple, that for that we will also need a Python environment, I mean a Python interpreter, which is not available by default on Windows. And the way typically this works, just as an example, when we ported and we did all the work in OpenStack, which is entirely Python based, what we do is that typically entry points are simply wrapped into executables that from there are starting, of course, the Python interpreter and the corresponding code. But not having one installed, we cannot do that. Hope that answered the question.
Does that mean that if Python were installed when the installer was run, then the CLI would have been
if
included
the Python is installed, then we have if Python is installed and all the Python scripts and so on and the modules don't have anything Linux specific, like signals and stuff like that, then it will just work.
Cool. Okay.
And for the second question, what is the current status, ability, installer inclusion of CephFS?
What is the current status for the installer inclusion? You mean for upstreaming it, or?
I noticed when you did the installer that it said Ceph CLI and it said the Windows RBD driver, but there wasn't an option for the CephFS. Was that included as part of RBD
Yeah, it's included by default.
Okay.
So as you saw, I installed it basically as part of the demo that I did right now.
And just curious about the stability status. Like, is it still considered under development, or is it like stable enough to be used, or what? Can you give a little bit of a?
Well, we are using it already, production-wise. We never encountered any bug report recently that hinted at stability issues and so on. So this is, of course, the first release. We advise, of course, our customers saying that this is, of course, the first release ever of Ceph that includes Windows. But we are very, very positive about the stability performance that we encountered until now.
Okay, thanks.
Very welcome.
And for our last question, how much demand is there for CephFS on Windows?
Okay, this is a fantastic question. So far, all the demand we see comes, let's say, to the community channels. We see some interest from emails that we're getting from users which are interested in everything. But I think that the most important thing will be to return to live events and being able to have the typical interactions that we have at worldwide conferences and so on. So hopefully the next Cephalocon and so on, in which we can really taste the pulse of the situation. Because right now, with the pandemic and everything, I don't think we can clearly assess how much interest there is, because especially large enterprises, they just don't adopt something off the internet. They need first to engage, discuss, and everything. That was, of course, our typical communication patterns we have previously with other open source technologies ported on top of Windows. Same thing happened for OpenStack. Same thing happened for example, in the networking space. So I would expect the same pattern to happen here as well. Open with switch was what I was looking for. So I would imagine the similar thing to happen to Ceph.
Okay. Well, that's all I see for questions. Thank you, Alessandro, for giving us a wonderful presentation.
Okay. Thank you very much for having us, and looking forward to the next talks.
Yes, thank you so much. I'm very excited about all this work. Thank you.